It doesn't matter what the equation is. It could be a very difficult equation, and I probably should have thrown one in that was a little bit harder. But you can graph anything. So what does it mean to solve this equation? Because that's really what we're doing. We're trying to graph that picture over there. The graph is a picture of the solutions. So let's go ahead and start this, and I'll talk more about what that means again. So what would be the easiest x-coordinate you could put into this equation? 1 is a nice one. It's not the easiest one. Okay, so what do you do then? You substitute into this equation, and then you evaluate. Get the vocabulary. You're going to substitute. I think I'll write here. And then evaluate. Okay, so if I put 1 in right there, I'm going to have 2. Is that plus 1 or times 1? Do you see a plus sign? Nope. And so anytime I replace a variable with a number, then I put in parentheses. So it's 2 times 1 plus 1. You may use a calculator if you'd like. I can show you fast calculator stuff. But what's 2 times 1? No, times. 2 plus 1 is? Okay. So that ordered pair is 1, comma, 3. Now, I'm going to try another number. What's the easiest number, even easier than 1? 0. So if I put in 0, I do 2 times 0 plus 3. What's that equal to? What's 2 times 0? 0 plus 3 is 3. Wait a minute. That can't be. Oh, it was plus 3. So I copied it wrong. That can't be. Can't have the same point. I copied my equation wrong. I'm sorry. It's 2 times 0 plus what number should I have written there? 1. I copied it wrong. So that's equal to 1. Well, let's put some more numbers in. And on the worksheet I have for practice, Michael, they give you the numbers to substitute in. It's substitute and evaluate. That's all it is. Okay, Nick, what number do you want to put in there? And don't make it huge. Can you put in negative numbers? Yeah, I know you would. How about 2? How about 2? And there's an easier way to fill in this table than that. But right now we aren't going to see that. So it's 2 times what? 2 plus 1, which is equal to 5. Okay, Michael, you should be writing this down. And then we'll just graph using these points. Probably should have been the first thing we did. And I don't know what, not normally the other teacher didn't teach it. I think you should know this. Because it works for any equation you get, anything. So if I put in 3, 2 times 3 plus 1 is what? 7. Is this hard? No. And let's do one more, 4. So it's 2 times 4 plus 1 is 9. You might notice something about as x increases by 1, what happens to the y's? They increase by how many? 2. Guess what number that is? That's the slope. Trying to get you to connect all those little pieces. So all we're going to do is graph these. Yes.
So when the kids are doing the Y are you wanting them to show?
They don't have to show their work if they can do it in their head. I just wrote it for them. If they can do it in their head. I've got some with fractions. They may need to show that.
Yeah. For X, you just use random numbers? Or
Any numbers you want. I would have started with 0, but somebody said 1. So we went 1. I'd like to have them go in order because then there's a quick way of doing the table.
it'd be like 2, 5, 7, blah, blah, blah.
Oh, yeah, because we're going to get a couple. I think I have 1 with fractions or 2 with fractions. So you're going to have to figure out how to do that. So this is 1, 3. Now, I know that those points should lie on a line because I know it's a linear equation. Michael, so if I don't get them lying on a line, Michael, then I did something wrong. So at 0, it's going to be 1. What's that called? That's a special name. Let's come back to that. At 2, I'm going to be at 5. At 3, I'm going to be at 7. Uh-oh. I'm off my graph, but that's okay. Because at 4, I'm going to be up here at 9. Because what's the slope? Do you remember? Look at your equation here. We just tested. Somebody has to finish that. But That's right, down 2, and then to the left one will work.
I missed that from what I,
Mhm.
guys, how many times do I hear you go, your iPad, your iPhone?
We shouldn't even have them out.
So I don't know why I'm seeing them. George, Houston, what are those doing now? You guys, I'm another teacher in the room. If I see them out, I'm going to just say, put them away. What your job is right now is to not have.
And I'm not going to talk that long. Then you'll have a chance to listen to your music.
What have you got going on with Bruce?
He's got his off as far as I know. Yeah.
It's like, close your iPad.
You don't have to have it open. What happened to your case? No, it's distracting for me too. Okay, Michael, what am I going to draw a picture of? How many more ordered pairs could I put into that equation? Could I put in a half, negative a half, negative 1? Is there any limit to what numbers I could put in here? No. So I have a whole bunch of ordered pairs that make that equation true. I can't list them all. So I'm going to draw a picture. That's what a graph is. It's just a picture. Pardon, I graphed all of these. 1, 3, 0, 1. I'm going to clean it up a little bit. 2, 5, and 3, 7. I was a little bit off my graph. Now what should I do with these points? Because all the points in between also lie on this graph. I'm going to draw my line. This has a special name. What's that called? Where the line crosses the y-axis. Michael, you should have this all written down and graphed by now. What kind of intercept? The y-intercept. And guess what number that is? That's this one. Just try to tie it all together. So there's a variety of ways to graph. When in doubt, a table always works. So I thought I should actually teach you that skill on creating a table. Is this one okay? Hannah, is this okay? Okay, and you guys have some tests to make up, but we'll get them done this week. Okay, let's try this one. Negative 2x minus 3. A little feedback here. So what's the easiest x value to put in? Now on my worksheet that I give you for homework, they tell you which x values. Michael, what's the easiest number I can put in here? No, easier. 0. So it's negative 2 times 0 minus 3. My goal is to get this right every time. So if I show a little work, I'll probably get it right. Gabe, what's negative 2 times 0? 0. 0 take away 3 is negative 3. And on the worksheet, they might not do 0. I would always do 0. Alex, how about the next one? What number do we just do? Let's try 1. So it's negative 2 times 1 minus 3. If you need a calculator, please use one. I want you to get this right. But this is good practice with integers. What's negative 2 times 1? And negative 2 minus 3 is negative 5. We're adding or subtracting. What's another one? 2. So it's negative 2 times 2 minus 3. I didn't need that first parentheses. I just wrote it. That's right. Negative 4 minus 3 is minus 7. Now, I tend to get lazy. I know some other people are lazy like that too. If these go up by 1, what are these doing? They're going what? Down by 2. So if this goes up by 1, this is going to go down by 2. Negative 5 to negative 7 is going down by 2. So let me do 3 and 4. Should we do this the easy way? This is going to go up by 1. So negative 7. If I go down 2, where am I going to be? Negative 9. Is that right? If I take negative 2 times 3 minus 3, I get negative 9. Don't need that parentheses either. So I don't care. You can either substitute. Once you figure out how to do this, this is a good skill to work off of a table. If this goes up by 1, we're at negative 9. If we go down 2, where am I going to be now? Elias? I'm at negative 9. Where am I going to be? Negative 11. So it's just another way of looking at the equation of a line. Why are we hitting on lines so much? Because that's what this class is about. This is algebra of lines. And it's a critical skill that we have to have as we go on in mathematics. And we all have to take 3 years of math. Actually, you have to take 3 more years of math. Mm-hmm. You need 3 years of math. But you have to take the MCAs as a junior, and that does go through our higher algebra class. So,
Quads, geometry, higher algebra.
right, that's what you're going to have to take. And we should talk about that, but let's finish these first because I didn't talk to them about that. Okay, so we graph 0, -2. There's the y-intercept. Whoops, I'm sorry, -3. I read my handwriting. I read the wrong thing. 0, -3, I would have caught that, I think. 1 is -5. Uh-oh. 2 is -7. I'm running off my graph, but that's okay. Can we use our slope to find some more points? If x goes down by 1, what does y do? Goes up by 2. Remember that? We go up by 2 over 1. And there it is. How many points do I have to graph? 2. I have to have 2. I get a line. But if I do a third one, and if it's not on the line, then I made a mistake someplace. So you better have at least 3. I think there's maybe 4 on the worksheet. Okay, ready? I don't want to go too fast. You don't have your graph there or your table. I'll pause for a second. Should have these done and then let you. Okay, so now I have y equals half of my x values. Well, what's still the easiest number to put in there? There, what's half of 0? I have no money. You're going to get half of it. How much are you going to get? Nothing. Okay, do I want to do 1? Because half of 1 is a half. Michael, I don't want to graph a half. So what would be a good choice? 2. So what's 1/2 of 2? 1. What's another good choice? 4. That half of 4 is 2. I like this. It's easy. 3, 8, 4. Look at this. As this goes up by 2, this goes up by 1. There's your half. If you hadn't made that connection, now's the time to do this. If this goes up by 2, Michael, this goes up by 1. Mathematics is nothing but patterns. If you like patterns and puzzles, then you should like math, because that's what it is. So I'm going to start at 0, 0. I'm going to go 2, 1. Then I'm going to go to 4, 2. And then I'm going to go to 6, 3, and 8's off my graph. So I could go the other way. So I'm going to go down 1 to the left 2. And we just tested on this. Oops, that's not good. I'm hoping that you did okay on it. I don't know yet because I haven't looked at them. Let me try this again. There it is. And we will go into applications of lines after we learn how to write equations of lines. So that's what we're going to do. But then we'll actually do at least one activity, maybe more than one, about writing equations of lines. Is that it?
Yep, that's
That's pretty good. Okay. This one's going to be harder. I gave you a hard one. -3/4 times my x, and then I'm going to take away 1. So I might have to show my work on that one. Well, I always like to do easy first. That's kind of just my plan here. What's -3/4 of nothing? Nothing. So where's the y value here? No, it's -3/4 times 0 minus 1. So it's -1. Now, I don't want to do 1 because I have to do 3/4 of 1, and that means I have to add fractions. Do you guys like to add fractions? No. I don't want to do 2 because I still have to do 3/4 of 2, and I'm still in fraction mode. What's 3/4 of 3? Is that still a fraction? What's the smallest number I can put in here and make this work? 2 doesn't work because 2 have fractions. I'm trying to avoid fractions. How about 4? So it's -3/4 times 4 minus 1. 4s will do what? They'll cancel. That gives me 1, but don't forget you still have a -3 here. So what's a -3 minus 1? -4. What's another number we could try, Michael? 8. And this is negative 3/4 times 8 minus 1. And I'll give you a little quiz on this, putting everything together. But we're not quite ready for that. So I'm going to divide the 4 into the 8, which gives me what? 2. You can use a calculator. Sorry, it's hard to read. It's negative 3 times 2 minus 1. What's this give me? Negative, what's a negative 3 times 2? Negative 6 minus 1 gives me negative, careful, 7. And let's say we did put the wrong one in there. When I graph these, I'm going to know. They have to all lie on a line. So I have, yes.
Does the x always raise up or the y always gets negative 3?
Yes. Marie noticed that if I increase this by 4, that this went down by 3. That's that number there. Keeps coming back and haunting us. So could we go up to 12 here?
Yeah.
Instead of doing the arithmetic with the fractions, which wouldn't hurt us, this is going up by 4, and this is going to go down by 3, negative 10. Oopsie. I could go the other direction. Could I start at 0 and go down by 4? Then what would happen to the y value?
Plus
It would go up by 3. What's 3 plus a negative 1?
negative 2.
3 plus a negative 1 is 2. And if I have the wrong numbers, they're not going to lie on a line. Not everything is a line, but I have 0, negative 1. I have 4, negative 4. I have 8, which is off my grid, negative 7, but it looks like it's on a line. Let's try the other one. 12, I can't put on there, but negative 4, and if you said it was negative 2, it would be down here. That doesn't lie on a line, does it? Okay, Missy, does that lie on a line? If we said that, did that wrong? No. I want it to be where?
14.
At negative 4, I have to go up here. I'm going to count 4 to the left and up 3. There it is, negative 4, 2. Lots of ways to check these things. This is a picture of things that lie on a line. So a lot of things are linear relationships. We can make predictions with those. Now, I will be collecting this and giving you points for it. So they're easy points. Yeah, that would be nice. My stapler is up here. Otherwise, put your name on both pieces of paper so I don't mess it up. Here's my stapler. And, you know, if we're not ready for the worksheet on this, we're not ready for it.